Hey everybody, this is Mr. Baker. It's time to take a look at our first review worksheet for the end of course test for Algebra 2. What we've really got here on the first slide, it's the top left corner of your worksheet. It's just a bunch of formulas. Of course, the quadratic formula right here. We've got three different ways of writing a quadratic equation. Vertex form, standard form, and factored form. And then a few little things. How to use standard form to get the x-coordinate of your vertex. The definition of I, and I squared is -1. All things that are going to be helpful while working with quadratics. So let's tackle this. All expressions equivalent to that big mess right there, 162x squared minus 72. Now, this is technically a factoring problem, and it really is pull out a GCF and then do difference of squares. But that's not necessarily how all of these tackled it, and it does say all, so be prepared to answer more than one. So there's a trick to this one, and almost any time we're trying to find things that are equivalent, what we can do is we can pick a number and plug it in for x, and that's a trick we've talked about before. I don't really like to pick numbers. Don't pick 0. It's too easy. Don't pick 1. Don't pick 2, because 2 plus 2, 2 times 2, and 2 squared are all equal to the same thing. Instead, I like to pick a bigger number like 7. Now, it's going to give us a really big value when we plug that all into the calculator. It's going to be 7,866. So that's not a huge value, but it's big. But the trick to this is that when we plug that in to all of these for x, the ones that are equivalent will give us the exact same value, and the ones that aren't equivalent will give us something different. So let's see what happens. When we plug in 7 for all of these, we get 7866 on 3 of them, which means 3 of them are equivalent. Now, it wouldn't be a bad idea to look at them and figure out why are they equivalent. This one looks like we just factored out a 2 from the original, and that's all that changed. Well, that makes sense. This one, once we factored out a 2, looks like they factored into difference of squares, into conjugates, 9x minus 6 and 9x plus 6. So that one makes sense as well. And how about this last one? Well, if you'd factored out an 18 in the beginning instead of just a 2, and then factored in a difference of squares, you would have gotten this. Or factored a 3 out of these parentheses and a 3 out of these parentheses. So, the fact that we can justify that, we didn't accidentally get the same value. Yeah, they really did reflect the original problem. Why not D and A? Well, both of those have parentheses squared. Now, if you square parentheses, you've got to FOIL it out. 9x minus 6 times another 9x minus 6, which will give us 3 terms, not just these 2 terms. The only thing that factors and gives us those 2 terms are if it's a difference of squares, like C and E had. All right, next up, we've got to change from standard form into vertex form. Well, vertex form we know is f of x equals a times x minus h squared plus k, where h and k are going to be your x and y coordinates of your vertex. So, but a is consistent across all forms of a quadratic, which means whether it's standard, vertex, or factored form, a is a, and in this case we start out with a 2, so our vertex form is going to start out with a 2. Well, the next part here, how do we get that? How are we going to get our h? Well, h equals, if you look in that first box, it's got that little equation there. With a fraction, it's negative b over 2a. Well, our b is positive 12, our a is 2, so negative 12 over 2 times 2. It's going to give us negative 3. Now, negative 3 is the x-coordinate of my vertex for this parabola, but it is not exactly what I put in here. Because think about it, it's with an x in parentheses like that, and x is lie. So that's actually going to say x plus 3. So Remember that. X's lie, I think I've said that about 50 times over the course of review. But don't try to use this positive 3. This positive 3 is what goes in the equation. This negative 3 is the actual x value we found. So the question becomes, how do I find k? Well, there's no direct formula for it, but I know the x value for the vertex. I can find the y value that goes with it just by plugging that x value into my original equation. Because that's what an equation does. It gives me y values to go with x values. So let's plug in that negative 3. And that's going to give me just 2 when we work it all out. And that 2 is the y value of my vertex. And that's going to be y's tell the truth because they're y's. So right there, that's going to be plus 2. So my vertex form is 2 times x plus 3 squared plus 2. On to number 3. The function f of x is given by the equation, and it gives us the equation. The values for the quadratic function h of x are in the table. So this is about comparing an equation and a table. And they like to do those comparisons, whether it's an equation and a graph, or a table and a graph, or an equation and a table. And sometimes they ask a bunch of different questions, but every one of these answers talks about the y-intercept. So I guess we should find the y-intercept of both of these. Remember, y-intercept, that's where we cross the y-axis, and the x value on that is 0. So we want to find the y value that goes with 0. In the table, that's easy to spot. It's right there. It's going to be that negative 6. It's not real hard to spot from an equation either. If we know that the x value is supposed to be 0, we can just plug it in. 0 squared is 0, plus 2 is 2, and 3 times 2 is 6. So f has a y-intercept of 6, h has a y-intercept of negative 6. So how far apart are they? Well, they're 12 apart. So it's already got to be A or B. Can't be C, can't be D. But we got to pay attention to which one is below the other. Each of these two answers says which one's below. A says h of x is below f of x. B says f of x is below h of x. So which one's below? Well, h is the one with a negative y-intercept. It must be the one that's below, since f is positive. So h is 12 units below f. That is what A says. So that's our answer here. This one, this was designed specially for a computer, so don't let the weird format. They wanted you to drag and drop stuff from here into the box or whatever. But don't be surprised if they have some weird formats on the end of course test. Now, it gave us the polynomial, but then it gave us the factored form, and it wants to know what values of x does the graph cross the x-axis. Well, factored form is the way to go on that. We factor things so we can find x-intercepts, also known as roots or zeros. And once we've got it in factored form, we really just remember that x is, no, not that kind of x. Let's try again. And if x's are going to lie, let's look at each one of these. The reason x's lie, by the way, is because we're really just taking the parentheses and setting them equal to 0. And that's going to change some signs. 2x minus 5 equals 0. To get x by itself there, we add 5 to both sides. That's where the sign change happens. But remember, we also have to deal with that coefficient. To get rid of that, we have to divide both sides by 2. Gives us x equals 5 over 2. None of these answers are in fraction form, so we have to turn that into a decimal, 2.5. Positive 2.5. We've already taken care of the sign change, so there it is. X equals 2.5. The other answers are going to come from the other parentheses, x plus 3. X's lie, so we're going to end up with negative 3, which again comes from subtracting the 3 from both sides. That's why it happens. But our answer is just that negative 3. Number 5 is a quadratic equation that's not going to factor for us. How do I know? Well, if you can't factor it after just a minute or two, then give up on it. And well, don't give up on it, but give up on the factoring, because we can always use the quadratic formula to find our solutions or to find our zeros. And the quadratic formula is given to you on the formula sheet. You should have it in your memory, but just in case it's there for you, we've got A equals 3, B equals 4, C equals 8. Plug those all in. Just make sure you take your time simplifying this. Don't try to just plug it into the calculator, hit enter. There's no plus or minus on the calculator anyway, and this one's not going to come out really pretty for you. We've got a 4 squared, these 3 numbers here, and these 2 numbers on the bottom. All we can probably simplify at the same time. None of those should be too much to handle. We get a 16 minus 96 inside the square root and a 6 in the bottom. Next, I would go ahead and simplify inside the square root. 16 minus 96 is going to be negative 80. And this is why you don't want to try to trust the calculator, because, let's face it, it's a negative inside a square root. Calculators don't like that. What do you do when there's a negative inside a square root? Well, you're going to pull an I out. It's not as painful as it sounds. But I've still got to finish simplifying this, because the square root of 80 will simplify, not all the way. Square root of 81 would be 9, but square root of 80, not quite as pretty. So we're going to want to factor it down. What multiplies to be 80? Well, first thing I think of are 8 and 10. 10 is 2 times 5. And 8, well, I can think of 3 things that multiply together to be 8, because that's just 2 times 2 times 2. It's 2 to the third. So how does that help me simplify my radical? Well, remember, when you've got a radical, we can pull things out. If there's 2 of the same thing inside, we can get 1 on the outside. So since inside the radical I've got 2 times 2 times 2 times 2 times 5, because that's what the 80 is, 2 2's inside will give me a 2 on the outside. Then we got another pair of 2's inside to give me another 2 outside to multiply together. And what about this 5 that didn't have a buddy? Well, he's stuck inside, can't come out. So what's this leave me with? I've already got an I outside times these 2 2's. That's going to be negative 4 plus or minus 4i square root of 5 over 6. Are we done? Well, not quite, because we can still simplify this if there's anything that goes into those 3 numbers. The numbers before and after there's plus or minus, and the number in the bottom. What goes into negative 4 and 6? Well, 2 does. So we're going to divide them all by 2 to simplify the fraction, which gives us negative 2 plus or minus 2i squared of 5 over 3. Now that's one answer, right? Well, no, it's 2 answers. We've got 2 boxes. We need to put 1 answer in each box. So it's 2 answers because that plus or minus. The plus goes in one box. So negative 2 plus 2i squared of 5 over 3. And the minus goes in the other box. Negative 2 minus 2i squared of 5 over 3. When you've got 2 boxes like that, they're really checking. Not only can you do the quadratic formula and solve it, but how well do you understand what that answer means, that it's really giving us 2 values. Number 6. It wants us to graph, but doesn't want us to draw the whole graph. It only wants us to plot the points for the x-intercept, the y-intercept, the maximum and the minimum. Maximum or the minimum, you're not going to have both, to the nearest half unit. So just pretty close, but doesn't have to be perfect. Well, one way to do this is, of course, to graph it on your calculator and trace it to find those points, or use second calc and go in to figure out whatever it is we're looking for. And that's a very good way to do it. But we've got some other ways to get there as well. The easiest thing to find should be the y-intercept. It's the only thing that a standard form really does a good job of telling us, and it's that constant, that last number. So negative 7 is going to be my y-intercept, which is way down here. So that's the y-intercept. Next up, while we're talking about intercepts, let's talk about the x-intercept. Well, that's where our roots are. So if we could factor this, that would help us find them. But guess what? Doesn't factor. It's going to be an ugly mess for us. We plug it into the quadratic formula. It's going to give us positive 5 plus or minus the square root of negative 5 squared minus 4 times 3 times negative 7 all over 2 times 3. Simplify again. Take your time simplifying it, or you could take everything inside the square root and plug it into the calculator. Be careful with your parentheses. It should give us, since negative times a negative comes out positive, and a negative squared is positive, it's all positive stuff adds up, 5 plus or minus the square root of 109 over 6. Well, I like that way of writing it, but it doesn't help you graph it, so you're going to need decimals. And that gives us, the plus gives us 2.57. The minus gives us negative 0.91. So what's to the nearest half unit for 2.57? That would be 2.5. For negative 0.91, I guess that's negative 1. And those would look like that. Well, we found the y-intercept. We found the x-intercept. How do we find our vertex? Our vertex is going to be a minimum because you can already start to tell that it's going to have a U shape going like this. Minimum is not the same as the y-intercept. The minimum will always be halfway between your x-intercepts, but those are kind of ugly x-intercepts. So maybe it's time to go back to that formula for h, which is negative b over 2a. Our b is negative 5, so it's going to be positive 5 over 2 times 3, which is 5/6, which as far as decimals go is 0.83 approximately. Now you don't want to plug in the 0.83. Be nice and exact. Plug in the 5/6. But just like we did in the earlier problem, to find the y-coordinate of your vertex, you're going to want to plug in the x-coordinate we found. So 3 times 5/6 squared minus 5 times 5/6 minus 7. Hit enter is going to spit out a decimal for us, negative 9.08, which is pretty close to negative 9, to the nearest half unit. 0.83 would be pretty close to 1, so 1, negative 9 is where I'd want to make that point hit. And they do ask questions like this, asking you to graph points instead of the whole graph, because there's a lot of different things that can be going on in the graph that you could earn or not earn points for. If you're going to try to trust the graph, make sure you're tracing and getting exact values, not just rough. There's a big U on the paper. You don't want to do that. Number 7, the last on this worksheet. A parabola has x-intercepts at 4 and negative 2 and has a maximum value of 12. Write the equation of the parabola in any form. Well, there's 2 good forms for us to work with based on the information they gave us. The most obvious one to me, since they gave us both x-intercepts, I'm thinking I want to do a factored form. Because if those are my x-intercepts, I want to use the fact that x is lie. That 4 is going to give me an x minus 4. That negative 2 is going to give me an x plus 2. And we're just going to throw them into the factored form. So once again, the positive 4 gave me, that's where those go, because x is lie. But that doesn't give me everything. I still don't know what my a value is, but I've got most of it. So what do I need to know to find my a value? Well, I need to know any other point on this graph. The y-intercept or the vertex or some other ordered pair. Well, I've got a maximum value of 12. And so that's going to go with my vertex. So I guess the vertex is the point I'm going to use. And the y value is 12, but I need the x value. Now, I don't have standard form, so I can't use negative b over 2a, but I do have my 2 x-intercepts right up here. Use your actual x-intercepts. Don't try to use the parentheses directly. You want to use the actual x values, because on a parabola, the vertex is always, the x-coordinate is going to be halfway in between your 2 x-intercepts. So we've got 4 and negative 2. And we just want to find what's halfway in between them, which we can get by averaging them. Add together, divide by 2. 4 plus negative 2 is 2. divided by 2 is just 1. So my vertex is at 1, 12. Well, how does that help me? Well, now I have an x value that I can plug in for x. I have a y value, 12, I can plug in for y. And now I've got something plugged in everywhere except for a. I should be able to find what a equals. 1 minus 4 is negative 3. 1 plus 2 is positive 3. So 12 equals a times negative 3 times 3, so negative 9a. Divide both sides by that negative 9. A equals, well, negative 12 over 9 reduces to negative 4 thirds. That's my a. Is that my answer? Well, I've got to plug it back in right up here where I had the rest of my equation. It's y equals negative 4 thirds times x minus 4 times x plus 2. That's our factored form. It said any form. Any form would do, and that's a perfectly good answer. I like factored form. Or maybe we would have done it a different way. Now, some things that we've found already are going to be helpful, like finding the x-coordinate our x-intercept. So I'm going to keep that here and keep this ordered pair because it was the exact same work we would do. But maybe instead of a factored form, what if I wanted to write it in vertex form? Because I'm given the maximum value, and it wasn't very hard to find the x-coordinate. So why not just plug that in? My x-coordinate is 1. My y-coordinate was 12. There's the 12. There's the 1. X is last, so it says x minus 1. Again, I haven't found my a. How am I going to find my a? Well, any other point. This time we've already used the vertex, but we haven't used a y-intercept or an x-intercept or some other ordered pair. Well, we've got 2 x-intercepts. Well, let's use one of those. As long as it's there, use the x-intercept. If 4 is, we'll leave out the negative 2, but we could have used that. But if 4 is my x-intercept, that's the x-coordinate. What's the y-coordinate? Well, on the x-axis is going to be 0. Y-coordinate is always 0 on the x-axis. Again, I've used another point to figure out an x-coordinate and a y-coordinate. I should be able to plug in those to find a, because now I've plugged in for everything except for a. Well, 4 minus 1 is 3. 3 squared is 9. So get a by itself, subtract 12 from both sides, and divide by 9. We saw that before, and that simplifies to negative 4 thirds. So if you went that route and you wanted to write it in vertex form, a very similar process. We still had to average our x-intercepts to find the x-coordinate of our vertex. Use the value they gave us for the y-coordinate. This time it's y equals negative 4 thirds times x minus 1 squared plus 12. Same a, regardless of which way we went. And still used all the information at some point or another. All right, so that's 2 different ways to do that problem. And that was quite a few different things to look at for the quadratics. Probably the hardest of our reviews because there's so much covered on there. I hope you've looked at these and used it to remember the stuff we've already done. If you're learning it for the first time, that's not what this assignment was really designed for. We're trying to wake it back up. But hey, if you know it now, you know it now. And I hope this was helpful to you. Check out the rest of the videos for the rest of our review, and good luck on the end of course.